Welcome everyone to our webinar, Lessons Learned on Multi-Prem Software Delivery. Thank you so much for joining us today. We're really looking forward to a great discussion regarding a new modern twist on an old problem. In this webinar, we'll be talking about delivering third-party enterprise software applications to on-premise or self-hosted customers. The challenges around packaging and distributing third-party applications are certainly not new, but we believe that almost all enterprise software vendors are actively modernizing their application stacks to take advantage of the strategic benefits of containers and Kubernetes. And as such, we believe that when it comes to tooling that's needed to deliver these newer, modern, cloud-native Kubernetes applications, many of these teams will find themselves at the crossroads of build versus buy. Our hosts today will be Grant Miller, CEO and co-founder of Replicated, and Mark Campbell, CTO and co-founder of Replicated. And with that, let's get started with a little background on how Replicated came to be.
Thank you, David. The quick backstory on Replicated is that Mark and I had started a separate company together about 10 years ago. That company was pretty quickly acquired by a publicly traded SaaS company called LivePerson. And so while we were at LivePerson, Mark and I were running the mobile team together, and Mark really had an insight in terms of what containerization would do to the future of enterprise software. Ultimately, he really believed that it would change the way that enterprise software was developed and deployed. And so we started Replicated with that same thesis right around the start of 2015. And so we've been running this company together for 6.5 years, and the mission has remained largely the same. The technologies have evolved a little bit, so it's not just about containerization, but we're much more focused on Kubernetes as the primary unit for application portability and deployment. But ultimately, the whole vision is enable software vendors to deliver a version of their product privately into secure enterprise environments. So instead of having to send out all of this data to thousands of different vendors, the enterprises can actually bring the applications to where the data resides.
Right, and so before we get started, I think it's important to talk a little bit about what is on-prem software, and is this a dying trend or like legacy, or is this the future of software? And it's going to require a couple of definitions of what modern on-prem software is versus legacy on-prem. And we at Replicated have recently worked with Dimensional Research to conduct a survey of independent software vendors about the future of on-prem software, whether it's growing or shrinking, and what they're seeing. And here we have a few of the results of this survey.
Yeah, Mark, when we started this company, I think that we had an inclination that on-prem software would continue to grow. And when you looked at the market data, like this, it was fairly supportive, but it was really hard to know. And so running this research report along with Dimensional was a really interesting insight. I think this surprised both of us in terms of how much growth these ISVs are seeing in their on-prem products. And so ultimately, what maybe the industry has sort of dubbed a dying ecosystem is actually becoming an even more powerful and important place for software vendors to think about spending their time.
Yeah, I mean, we definitely see it as a good way to deploy software with the prevalence of the cloud, and everybody has equal access to the same infrastructure. And we see the growth of on-prem software, and seeing the actual results of ISVs and seeing the growth that they're seeing was really eye-opening to actually have that validation and say, what we're seeing is not just us; it's across the industry as a whole.
Yeah, and this research report is available. I think we published another webinar on that, which is worth watching and downloading the whole report, because it's really great insights into where this market is today and where it's going. But let's kind of go to next, talk about why this is such a big market. Ultimately, I sort of mentioned this idea of not sending data out to thousands of different applications, but instead bringing the applications where the data resides. And that's this concept we talk about with data surface area, right? So enterprises, if you're using lots of different hosted applications, you're basically copying your data and you're handing it over to another vendor, another vendor, another vendor. And this is why there's like all of these, ISO 27000, SOC 2 compliance, et cetera, all of these sort of certifications are basically an attestation to the ability for a software vendor to actually manage your data. What folks don't really realize is things like FedRAMP, which is a pretty big push for folks that want to sell in the federal government, you don't really need that if you can deploy your product on-prem, right? You're only doing, going through that process and getting that certification because you have you want to host the software for these government customers. And so when we look at these sort of opportunities around, what's happening in the market, right? Like when we started the company, we referred to this as the post-Snowden era. So this kind of captures this idea that, the countries, the continents, folks like the EU would start to think about the way that data moves around the world and be more concerned about, who has access to it. And so you've seen things like GDPR, the CCPA, Privacy Shield, all of these different challenges to sort of the way that data moves throughout the world. And it increasingly puts more sort of constraints and requirements on software vendors that can be largely sort of avoided by just delivering a version of your product into the customer's own environment. And finally, I think the piece here that matters is around control and continuity. So when an enterprise thinks about all of the different sort of tools that they're going to use, we've seen where SaaS companies go out of business and then like end of life an API the next day, or you end of life a product, or this isn't necessarily happening to lots of customers, but like there's some of these organizations are shutting down different cloud accounts because they have different political philosophies. And so it's just the ability for a vendor to shut out access at any moment for whatever reason is oftentimes not a very business continuity friendly way to run software. And so by allowing the vendor to package up the application, deliver it to the customer's environment, they have full control over the update cycle if it's up and running, and then it's never going to be taken away from them until their license expires or something.
Yeah, so while we've talked about why on-prem software is a big market, one of the things that's worth talking about is like how have enterprises been receiving on-prem software today? Traditionally, if you think back to the legacy of the original versions of on-prem software, it was deployed as bare metal servers. It might just be that you would actually receive a box, an actual hardware box that has the software pre-installed on it that you rack and stack in your data center, and that's how you got the initial installation of the software. Since then, we've seen a lot of advancements in technology. The first was the movement to virtualization. Instead of actually tightly coupling the hardware and the software together, you could get an OVA or some kind of a VM image that the enterprise could just run, and then it became easier to update, easier to maintain, and then there was a separation where the enterprise could be responsible for the hardware, and the software vendor shipped just the OVA, including the operating system and everything that's required to make it run. And then move forward to the next step. After virtualization became the cloud, from AWS, Google Cloud, Azure, all of the cloud providers, now everybody has access to the same virtualized infrastructure, but it's also programmable compute, and you can just on demand request it. And it's more than just a VM, but now you have access to storage and load balancers and networking and all of these different cloud services. And we move from an OVA to more of an AMI or an image that's compatible with cloud providers. Since then, Docker came out. Grant mentioned that earlier. Docker came out quite a while ago, and it created this software portability concept. And a Docker container was able to run anywhere on any machine as long as it had access to a Linux kernel. Docker containers are the basic compute of portability, but Kubernetes was needed on top of it. And Kubernetes has been out for a while and seen crazy great adoption. And Kubernetes creates an abstraction on top of it with a common API to deploy services. So instead of just deploying a Docker container and then figuring out how to string them up, because rarely is an app a single binary or a single container, but it's a collection of different services that run, Kubernetes allows every vendor, every enterprise, every operator who's running software to have a same common API to deploy, to manage, to update, to check the health, to do everything with that software. And the latest trend right now, go ahead.
Yeah, no, I think it's a really interesting point, because there's a key difference that's happening now versus previously. So the old world of delivering software on-prem was very bespoke and was very custom. And so I always talk about this idea that there's this, there was almost this operational tax on top of every single application that an enterprise was going to deploy in their own environment. And that tax was basically like, all of the headcount that you needed to manually operate that application, figure out how to run it. There was a 127-page install guide and a run book that you were following. It was very manual. And so that tax, you paid it for every single application you wanted to deploy privately in your own data center. But over time, what's happened now with Kubernetes is because of exactly what you're talking about, this idea of a common API, instead of a variable cost per application, right? Like this, I need every application I'm gonna run, I have this tax. We now have a fixed cost. And so an enterprise can set up a single Kubernetes cluster or maybe a handful of clusters and then use the exact same processes to add new applications in one at a time. And it's a marginal increase. It's just a tiny bit more effort to add every single new application. And so what we're seeing is sort of the shift away from that variable cost to a fixed cost. And it's a much smaller fixed cost. Pay one time, and then you can run as many applications as you'd like at scale. And for vendors, they're actually saying, look, instead of me trying to figure out how to write all of this orchestration, and basically, we always joke because everyone built their own orchestration and scheduling before Kubernetes, right? Like Uber had Peloton, Facebook had Tupperware, Square had their own version, Twitter had Mesos. Everyone was doing some version of this if they were really deploying applications at scale. And so now that we have this common API, this common substrate for how applications can actually be deployed reliably, well, that's really important for enterprise software. And so we're at this transition point, which is every software vendor is moving their architecture to Kubernetes. And they're doing that because it takes some of the complexity of building a reliable application out of the application code and puts it into the platform code. And then the other advantage is it's becoming this universal substrate. So enterprises are pushing their vendors to deliver them a scalable, reliable, Kubernetes-based version of their product. So it really is this sort of perfect storm in terms of supply and demand coming together.
Yeah, I think one of the other things to point out is we've been talking about the API to deploy that software, but even after it's deployed, the Kubernetes API is an API that a lot of enterprises know and have tooling and integrations into their environment to do things like security scanning and monitoring and backup and everything like this. So getting into that common API, there's a huge benefit to deploying your software that way. So given that, let's move on to what do you, if you're a software vendor and you're thinking about shipping your app to an enterprise, what do you want and what does the enterprise want in order to successfully deliver and to receive software? I think the first part is you need a mechanism to distribute that software. You need to think about how are you going to ensure that you can distribute it to any number of enterprises at scale, securely, meeting their criteria. You don't want to distribute one-off credentials to everybody, and you need to be able to have a license so that you can ensure that they're using it, and when their license expires, it no longer works. You have some kind of ability to package that application up, run it in various environments, including disconnect the hardest environments, right? The disconnected, air-gapped environments that have no outbound internet access at all.
Yeah, there's a lot even more than we're showing here. I think ultimately, it's about integration, right? It's about finding a way to integrate with the existing tooling that your end customer is going to use, maybe to secure it, to monitor it, to observe it. And so you need to figure out how you want to integrate with all of those different tools. Because what's interesting is oftentimes it's not just one tool that they're going to be using. It's not always Prometheus, right? Sometimes you need to have a little bit of an abstraction around this in order to integrate with all of your different customer demands. And then the final piece that we talk a lot about is being able to really support this from a day two perspective. So not just get it deployed once, but how do you make sure that it's operationalized for the end customer to update and to actually operate from a day two perspective. And one of the things that we've built around this is a framework for troubleshooting It's open source, so even if you're going to, sort of the whole theme of this is build versus buy. So even if you would end up building your own tooling to actually deliver your application, I highly recommend that everyone, check out troubleshoot.sh as a way to embed some amount of troubleshooting tooling into their distribution, so that their customers, don't have to pull every single log file by hand and look at it and redact it and send it off to your team.
And when we think about, the challenges of building to ship to your enterprise customers, one of them is that all the enterprise customers, Kubernetes is common, but enterprises have opinions about how to run it. They already have investments, they already have infrastructure in place to run Kubernetes. And one might be on AWS, one is going to be OpenShift and Azure and VMware bare metal. And while Kubernetes creates this common API across all of them, there are like little unique differences per environment, per provider of Kubernetes that you need to think about, and it increases that work a little bit. From, if you have one customer on AWS, you could deploy to another one that's likely on AWS also, but the first time you want to go to OpenShift, you end up with a different security model that you need to think through, and how your application is going to be updated and managed in that environment.
Yeah, I think, in this, again, there's tooling you're going to need to build to validate that your application can run across all of the whole spectrum of different customer requirements, right? If you were talking about like, okay, hey, we want to build out a Helm chart and deliver it to 2 customers, like that's definitely a very strong use case for build. You don't need a lot of extra tooling. You can do things very manually. But if you're going to end up delivering your application to hundreds or even thousands of end customers, number one, each of those customers is going to have slightly different requirements, right? So it's like the Venn diagram largely is going to be the same in terms of its Kubernetes. There's a lot of things that are similar, but then there's going to be some customers who don't even have a Kubernetes cluster. And so this is where, having a Kubernetes distro that you can easily install is going to be important. Some customers are going to have their own cluster of choice. Some customers are going to have an air-gapped environment. And so you really need to think about how are you going to satisfy the needs of the full spectrum of customers who are across, this sort of different life cycle. If you think about the technology adoption life cycle, where you have early adopters and innovators and early majority, et cetera. Well, where is your customers going to be across that entire life cycle? And so you need to be prepared to support the customers who don't have any Kubernetes experience, and then you need to be prepared to support the customers who want the most advanced, deployment with a customized patch and a GitOps pipeline. And I think it's really important to understand all of the different options that customers might want. And then on top of that, if you're delivering to thousands of different customers, it's actually really important to think about the tooling that you'll need to build for your own team, right? Because you're not going to just have, a single developer deliver a Helm chart to 2 customers. You're going to be engaging a QA team, a support team, a release engineering team. There's going to be folks, from the sales engineering side. And so all of those people will need to cross-functionally collaborate on the successful implementation of hundreds, if not thousands of customers. And so you'll need some type of internal tooling, dashboards, et cetera, that you can use to show those folks like what's going on with these customers, who has what license, what channel are they assigned to, how does this supposed to work, like what are they doing day in and day out, what are the adoption rates across the board, do you want reporting around what people are actually doing? There's a lot here you should think about. And when you talk to companies like Palantir, they're pretty secretive about their product process, but they've built all this tooling internally. Same with GitHub and GitLab, and folks that have been doing successful on-prem deployment at scale for a long time have all built a fairly consistent set of tools to make that possible. And so that's really what you're thinking about.
Yeah, and I think we've talked a lot about what enterprises want and what they need in order to run it. But as enterprises are adopting Kubernetes and they have pretty mature DevOps practices, it's important to also think about what do they specifically not want. What would be a turnoff to them to receive the software? And at the core, the reason that they want Kubernetes, as we've been talking about, is that common API. It makes it easier for them to adopt an application and run it and manage it and monitor it without any custom bespoke process, no manual management. They want to be able to just run and install the software and use their existing tooling, their existing process, their automation that they have, and rely on their entire pipeline that they have to get software from third party into their air-gapped network and then deploy it into their infrastructure.
Yeah, it's so important to avoid any type of manual management and manual process if you're really trying to help enterprises succeed at the consumption of your application. And so, oftentimes, and there's just little things like we'll see people be like, oh yeah, you just edit this file and you upload it there, and it's like, well, how else can I get it in there? Can I put it in through a CI/CD pipeline? Can I do this? How do I make sure that I'm putting in the right values? What happens if I, fat finger a value? Is it going to crash? And there's a lot of sort of interesting challenges that you have to think about when you are delivering this to a customer. If you're going to deliver Helm charts, like one thing we always find is that folks have to continuously expand the number of templated configuration options, right? So, because again, you have 1,000 different customers. Many of them have slightly different preferences. They might be using, some like sealed secrets or Vault or some other tooling to actually manage secrets. And so they're going to continuously ask you to make more and more of your product templatized and push for you to actually, make it so that you eventually have a very large manifest of configurable items.
Yeah, so all this leads up to the question, if you need to ship on-prem software to your enterprise customers, should you build it on top of the existing Kubernetes application that you have, or should you buy something that works already for that? So to get to this, there's a lot of different considerations that I think we want to talk about here. All of these should be factors that you weigh when you decide, do you want to build it or do you want to buy it?
Yeah, and I think it's important to sort of recognize that there's several factors, and they actually impact different people as well. And we'll talk a bit about that in terms of who actually is impacted by each one of these. But let's go ahead and walk through them, Mark.
Yeah. So the first one that we want to talk about is the cost associated with building versus buying. They both have a cost on them. So the cost on buying is relatively easy to think about. It has a price tag, and you're going to pay a fee to purchase the software. But the cost of building your own solution isn't always as obvious. It seems like this is the time it's going to take us to build it, and that's a huge part of the cost, definitely. But there's
I don't even know if it is the most important part of the cost, though. I feel like the time it takes to build is that's like the upfront fee, but there's such an ongoing amount of effort that's required to actually successfully deliver a product like this, right? So I always think about it from the perspective of, and look, again, it depends on how big your organization is. If it's a two-person org, like sure, like you can build something and get it out to 2 customers, no big deal. But if your organization is quite large and you're thinking about how do we really operationalize the delivery of this Kubernetes application into customer environments, and you have multiple products, then you really need to think about the tooling that you're going to build and who's going to be responsible for the ongoing improvement of that tooling. Because not only do they have to continuously keep up with an ecosystem that is moving fast, like the Kubernetes ecosystem is, but they also need to be thinking about customer requirements and customer requests, right? If you start to scale this out to hundreds or thousands of customers, you're going to see different requirements. And so you're going to need to dedicate not just engineers, but probably product management, maybe some amount of security time, because we're going to make sure this is architected very securely. And then you realistically, if you're going to roll this out to lots of different internal teams, right? So you have multiple products, then you almost want to have a customer success organization that's helping your internal teams adopt this tooling. So you need some type of evangelism. It's actually a lot of work to get people to use software. Trust me, we know. And so you have to put the time in to actually have this happen if you want this to be successful, right? We think this can be a massive part of any business. And oftentimes for many of these companies who are making the transition from an existing on-prem installation to a Kubernetes-based on-prem installation, it already is a massive part of the business, and there are people who are focused on building that tooling. And now you need to retool that entire organization to build something that's Kubernetes native and Kubernetes first, and they just might not be ready to do that.
Yeah, and moving on, there's support. Your engineering team, your DevOps or SRE team knows how to support your application on Kubernetes, but the tools that they're using to do that are probably not going to be compatible because enterprise customers want to run it in disconnected air-gapped environments. You're not going to have control access. You're not going to be able to SSH into nodes. And so when something goes wrong, that your enterprise customer, it's a large customer, needs to have you help get that running again, and you need to think about the tooling you need to build to support that. Documentation.
Yeah, it really is like building a totally separate enterprise software product.
Right. Documentation is very different. There's a lot of SaaS companies, a lot of SaaS products have internal admin tools that you use, and part of it's handled by the team, at you as a SaaS vendor are running, but you need to document and provide that type of functionality, and you need to think about documentation for release notes. A SaaS service is continuously delivered. On-prem software, they have to, the enterprise has to get release notes, understand how to install it, how to update it, how to configure it, how to troubleshoot it, how to roll it back if something went wrong. Like all the administrative tasks that aren't included in a SaaS application, you need to include in documentation, plus just like additional documentation needed to run the platform itself.
Yeah, exactly.
And then the last part is maintenance. So we covered that. So let's move on to the time to value. This one's a little more obvious. Like if you're looking to ship to your enterprise customers, when you're thinking about build versus buy, if you buy, you can ship relatively like immediately by integrating a Kubernetes application in and then have it available for your enterprise customers. And if you build, it takes engineering time.
Yeah, I mean, not only engineering time, but you need to again, there's product, there's product work here because you have to discover the requirements. There's training work that needs to be done, and so I think and it's funny. Sometimes I feel like we're preaching to the choir with this because most enterprise software companies sell a build versus buy story themselves, and they understand the sort of like trade-off for their product. And they're like, well, of course you should buy this from us instead of trying to build analytics internally or some version control system internally. But when it comes to buying other products, sometimes it's hard to see how much work it goes into actually doing that side of it. So if we like, I think one of our customers, HashiCorp, talked about how we were able to get them to market 6 months earlier than they would have had they actually built all of the tooling that they needed internally. And so for a company like HashiCorp that's growing so quickly, I mean, 6 months is a massive gain to be able to speed up your company by that type of by that type of speed. And that's just an estimate. So it's like, ultimately these projects take longer than you expect. There's more discovery that happens, and you realize that it's going to take, no software project gets done in the amount of time that it's initially scoped to. So.
Yeah, and when we think about actually what it would take, the time to value to build it yourself, you should really think about it as it's a whole separate product. It's not, you want to build it in a way that you can scale it out to enterprise customers, and it's not going to continue to take time and resources from the team. So it really is a completely separate product line that you're going to build, which has all of the phases of normal product development, from product management, defining the scope, to development, to a QA process. You have to write tests and automation around it, delivering it, and then thinking about how you're going to maintain and support it out in the field.
Yeah, I think there's a really compelling use case, in sort of analysis when for someone on a customer success team, right? When they are thinking about buying a platform to actually help them do this, really, what they're looking at is saying, I can get the best practices from a partner, and then work with them to actually implement this with my customers and my team. And so, a really good platform is going to provide a bunch of information about how customers are actually using your tools. What are they adopting? Are they updated? Are they upgraded? Do they need any help? Like, are they happy? Are they able to give me the type of self-serve experience that I want to provide to my end customer versus, if I'm a customer success leader and we're building this, I end up being the voice of the customer and thinking through like, okay, what does a customer really need? How should this work? What's going to make them successful? And there's just a lot of considerations that need to be made. And ultimately, I think it's time not spent with customers. It's time spent thinking about, delivery versus thinking about value through your product.
Yeah, and the same is true for the customer support side. When you think about build versus buy, nothing's going to ruin the experience more than the application being down for extended periods of time, or a long drawn out support process that's consuming both your team as a software vendor. You're putting a lot of effort and resources into helping the enterprise get back up, but it's a very asynchronous back and forth process since you don't have access to the infrastructure, to the environment. And so you're actually taking resources from that enterprise also by asking them, can you send this log file? And they grab the log file. Grant mentioned earlier redaction. They're going to go through a data loss prevention program. They're going to look through it for anything sensitive, remove it, send it to your engineering team, who's going to look at it and say, oh, well, that's interesting. Didn't give us exactly what we need. Now we need this log file. So you go back and forth. And that just destroys confidence by the enterprise. They want the application up and running. They need something that just works. They don't want to be dependent on your team, and you don't want them to be dependent on your team just to keep the software running. They want to be able to self-remediate these types of problems. They want the software just to work.
Yeah, I think, Mark, one of the things, we kind of talked about this earlier, but there is just, the cost sort of comes into this idea of there's so many resources you need internally, and ultimately your team is, if they're building this tooling to distribute your application into customer environments and to make sure that it's easy to support and it's easy to get insight on, well, they're just not building the value that your company is focused on, right? We think about this as kind of sort of table stakes or undifferentiated overhead type experiences, right? And it's just not where an enterprise software company wants to put their best engineers, the best product people, their best security engineers. They want those folks focused on the real value and the real reason that the end customer is buying the product.
Yeah, so given all that, Grant, I think the question is, if I'm a software vendor and I want to ship my enterprise software, I have a team of developers. Like, can I give them what I want? How do I think about starting to make this decision?
Yeah, I think, there is a pretty clear amount of work to be done to actually build this really well. And, for organizations that have been doing on-prem software for years, it's about managing the various releases that you're giving to customers, understanding who is on what version, how, creating some type of licensing tooling and entitlements, understanding what the end customer experience is when they're actually deploying it in their product in terms of configuration and troubleshooting. The most important thing you get if you are building this yourself is if you have if you really have specific requirements that are not met by a platform, right? Or the funny thing is every software vendor thinks that they are a custom snowflake and that their product is is so much different than everyone else's, and they do things in this really special way. Sort of newsflash is like, they're not. Like, nobody's products are really that different. There's probably 20 different patterns out there, but like most people fall into one of 20 patterns. And and so with that, it's like, yeah, you don't necessarily need to buy that because you're shipping an operator or shipping a Helm chart. It's like, that's all going to be provided by the platform. So but you can customize all of the look and feel if you're building this, right? You can put your best designers on it. You can put your best people on it, and you can really, you can invest, probably millions, if not tens of millions of dollars into the actual development of a product like this to make sure that you have a world-class experience for your customers and for your team to actually scale this out.
But
And I think it'd probably be worth it.
Yeah, exactly. I think if you do that, it would be worth it. It would be great. And then when you go to ship to the next customer, there's just something net new you have to add on top of that. That's not going to be trivial. Like, building something very specific for one customer um, is is tractable. You can do that, and then as you start to expand that footprint, that's where the challenges start to become. And you're starting to think, now I have to start making these abstractions. I have to start kind of normalizing the platform so that I can achieve the thing that I've built and make sure that it's compatible with 10, 50, 100, 500 different enterprise customers.
Right, but if you have a handful, of really talented people that you put onto this product, and you have them build some great tooling internally, it's probably going to be great, and it's going to be something that that you should think about like a new product line, and it's going to add value to your company. And just like all software is valuable, it's going to make your end customer experience really great. I'd argue probably not better than what you could get from a platform that's already focused on this completely, but it's going to be good.
Right. So let's also talk about the business continuity aspect if you choose to build versus buy.
Yeah, I think this is one of those things. Whenever I talk to executives at enterprise software companies, and they're thinking about, or they already have their own tooling, or they're thinking about building their own solutions, oftentimes it's sort of your perspective of like, oh yeah, like we just need a couple engineers to build this out. And sure, even if that's true, the question is, if this isn't core value, is that team, is the product manager, is the security person, are this the engineers who are working on this, are they going to stay on this team, right? Is this the thing that they want to work on? At GitHub, we always heard from the team there that no one really wanted to work on GitHub Enterprise. It just wasn't as sexy. Everyone wanted to work on GitHub, and so it was hard to retain folks to work on GitHub Enterprise. Sometimes they come in and then try to move to a different team. And so you end up losing those folks over time, either to other parts of your company if you're lucky, or they leave your company completely. And so now you have a product or a tool that you've built out and no one really knows how to manage, right? I think that any kind of product like this becomes legacy code basically the day that you're done writing it, because it's just not a core part of the functionality. It's not a core part of your business. And so there is this really important sort of aspect of business continuity. And when you work with a partner, I mean, the whole point is like, it doesn't matter if your team leaves and then 6 months later you hire someone else to manage it, or you put a consultant in there in the meantime. Like, a customer success organization at a platform like Replicated is going to spend the time to onboard your new team members and teach them how to use all the tools. And so this is really the important piece here, is you're going to find that what happens over time is you have new folks come and go, and as long as they can get trained up and be made successful, it doesn't really matter. But in a world where it's an undocumented tool that was written by a great engineer who only spent 3 weeks on it, and then it's it hasn't been touched since then, that's not really setting the next person up for much success. And ultimately, I think this is probably one of the more important products. Like, you're talking about delivering your product to your customer's environment. These are big customers, right? These are generally not like the SMBs. These are your largest enterprise customers. And so it's almost critical that you have the continuity of a platform that's going to be there in the long run.
Yeah, I think it's important to talk too. You mentioned it's important that part of the product, the installation, the upgrade, the support experience works really well. It absolutely does, but it's non-differentiating. Your customers aren't buying your product because it has a good installer, or you can remediate problems when it fails quickly. All of your time, they want your product to work, and buying and getting something that works allows you to free up all of the resources inside your organization to focus on building out your core product, adding more value, addressing customer requests and demands inside the core product that you're shipping, giving you that ability to put more resources into what's actually a competitive advantage for your product, not the installation experience, not the upgrade experience, or the configuration side of stuff.
Yeah, it's so true. I mean, I think this is the foundation of it. It's particularly for companies that are growing quickly, every resource that you put somewhere else is just not going to the most important thing. And in the beginning, when Kubernetes was really sexy, a lot of engineers wanted to work on these things. And now we're seeing those companies come back to platforms like Replicated to work with us because those folks moved on, or they don't, hey, like this isn't really working for the latest versions of Kubernetes, or it isn't integrated with the latest tools. And so, if companies want to see that kind of HashiCorp growth, I think they will focus on what they do well, and then allow a partner, a platform to provide the thing that they do well. And this is we have competitive advantage, but it's also what economics calls comparative advantage, and that's it. It's like focus creates advantage.
Yeah. So let's go back. I mean, we talked about a lot of different factors that go into the decision matrix of do I want to build, do I want to buy? So I think it's good just to take a minute in here and review the whole list of them.
Yeah. So that cost side, I think is obviously pretty crucial, and it captures a lot of this. But on the build side, you're talking about the headcount, the opportunity cost, and the time. And then on the buy side, there's clear cost, right? You're going to pay a vendor to access their product, and you're probably going to pay them some amount in a recurring and ongoing fashion. Both of them can be high cost, but I think the cost of buying is more clear, and it's more upfront, and it's more sort of defined. The cost of building is much more opaque, and I think hides a lot of its costs over time, particularly in terms of that business continuity side, as well as experience.
Yeah. I think, Grant, one thing is, in the spirit of the webinar here being, build versus buy, but moving it to a higher level, not just on-prem versus, build, do I want to build my own on-prem installer or buy a platform? But at Replicated, we make a lot of decisions too about what do we want to build software or buy something that's off the shelf and run it internally. So I was thinking here we could talk a little bit for a minute about, how the framework that we have inside our organization about how we make that decision.
Yeah, it is interesting, and I think it's as we've matured as an organization, we've realized more and more often it's better to buy. I think early on there were projects that we were building internally. I think about some internal like sort of CRM admin type tooling that we built out that was built by a single person who just like didn't really think about anyone else's customer experience except for their own, right? It was just, how do I want to use this, and what's the best way for me? And ultimately, that just creates a product that when that person leaves, it became very hard for us to actually continue to use it. And so, I think this is a very common problem for internal tools and technologies. Even things that we've done, with using some amount of off-the-shelf software, like tying things together with Zapier or Airtable. Some of these processes are a bit opaque, right? And they don't really provide enough context around like what happened, and they're linked to one account. So I think even when you buy, it's very important to engage a couple of people and to maybe work with a customer success team to make sure that there's more than one person who knows like kind of how things work. But and if you do lose your people that were running that platform, at least engage the customer success team when you hire new folks and you want somebody else to be able to help you. Ultimately, the nice part is like somebody is an expert on how things work because they work for the platform vendor. So somebody can always help you out versus when you're using open source tools, or you're using these sort of more like SMB platforms, it's a lot harder to actually get the assistants to understand what you're actually doing.
Yeah, I think what you just mentioned is super important. I want to like kind of talk about that for one more second, and that's build versus buy. I can sometimes think I want to write code for the build, or buy meaning I take something off the shelf or some open source components. But we on the engineering side at Replicated have definitely taken in the past 3 open source components and glue them together through some integrations, and then we just kind of manage that glue code that integrates them all together, thinking, oh, we're going to use something that's a little more off the shelf, and we're buying and we're saving ourselves some time. And that glue code it's a product too. We end up having to maintain that a lot, and anything that we can find that just they're focused on the actual solution that we're trying to deliver is just always easier in the end for us.
Yeah, I think that's exactly it. Well, cool. Thank you so much for joining me for this, Mark. It was fun.
Yeah, it was a good conversation. It was fun.
All right, thank you both to Mark and Grant for that presentation. And DZone gives a big thank you to Replicated again for providing us with that webinar. And we hope you all have a great day.
Thanks again.